Welcome back to Cancer Conversations, a podcast where we discuss all things cancer-related, creating a space for those who want to develop a greater understanding of this awful disease. Thanks for tuning into this episode of The Genes Behind Cancer, a genetic exploration, where we bring experts on the podcast to explain different genetic predispositions to cancer. I'm here with my co-host, Anna. What are we going to be talking about today, Anna?
Today we're going to explore the BRCA1 and 2 genes with our welcome guests. Thanks so much for being here today. Do you guys think you could introduce yourselves and tell us a bit about your experience with the BRCA1 and 2 genes? Why don't we start with you, Dr. Vo?
Thanks for having us. I'm Dr. Vo. I'm a genetic oncologist with 20 years of experience studying the BRCA1 and BRCA2 genes.
So great to have you here, Dr. Vo. How about we go to you, Dr. Martinez?
Hi, Bree. I'm excited to be here. This is such an important topic to me. I'm a doctor of molecular genetics, specializing in the BRCA1 and BRCA2 genes.
Thanks for joining us today, Dr. Martinez. Let's go to you, Dr. Webb.
Hey Anna, thanks for having me on your podcast. I'm Lily Webb and I have a PhD in molecular and cellular biology. I've been studying the mechanisms behind the BRCA gene mutation and a potential for targeted therapies.
I'm glad you joined us today, Dr. Webb. Last but not least, Dr. Woods.
Good to be here, Bree. I feel so proud to join all of these esteemed scientists and, of course, Bree and Anna. My name is Dr. Woods, and I'm an epidemiologist studying the prevalence and impact of the BRCA gene mutations in various populations.
What a wonderful group we have here today. We really appreciate all of you taking the time to join us. Let's start at ground zero. Dr. Vo, do you think you'd explain to our listeners how genes can even cause cancer?
Of course, this definitely can sound confusing at first. We all have genes called proto-oncogenes, which are genes that usually help cells divide and grow to make new cells, or to help cells stay alive. However, when a proto-oncogene mutates, or if there are too many copies of it, then it can become activated when it's not supposed to be. This is called an oncogene. Oncogenes encode proteins that promote cell division or prevent apoptosis. Promoting cells division may lead to overactivity, which can cause uncontrolled cell division and create tumors. However, that's only one way genes can cause tumors. For example, the bronchogenes are tumor suppressor genes, which are supposed to help prevent cancer. However, when mutated, they increase the risk for cancer.
Thank you for that explanation. I already feel more knowledgeable. Dr. Martinez, do you think you could discuss how the BRCA1 and 2 genes fit into all of this?
Absolutely. So the BRCA1 and BRCA2 are genes that everyone has. They are tumor suppressor genes, which are genes that can aid in preventing tumors by helping to maintain cell growth at the appropriate rate. However, some people have mutations in these genes which can greatly increase the chance of developing breast and ovarian cancer. If one of the two copies of either gene is mutated in the germline, then a person would have hereditary breast and ovarian cancer syndrome. This syndrome is considered autosomal dominant, meaning that it occurs on one of the first 22 non-sex chromosomes. Specifically, the gene for the BRCA1 protein is found on chromosome 17, and the abnormal gene only needs to be passed down from one parent for the mutation to occur.
It was a lot of helpful information there. Thanks. Dr. Webb, do you think you could explain more about the impact of this mutation?
Definitely. As Dr. Martinez mentioned, this mutation greatly increases the risk of breast and ovarian cancer. Only 0.25% of the population carry the mutated BRCA1 or BRCA2 genes, but around 3% of breast cancers and 10% of ovarian cancers result from the mutation. Perhaps even more alarmingly, an estimate of 55 to 65% of women with the mutation will develop breast cancer before they turn 70, compared to the statistic of the general population of women, which is 12%. Women with the BRCA1 or BRCA2 mutations who overcome breast cancer also have a higher likelihood of it recurring. Cancers resulting from BRCA1 mutation are also more likely to be triple-negative breast cancer, which is a type of breast cancer that doesn't have estrogen or proestrogen receptors. TNBC is a more aggressive type of tumor. It has a faster growth rate, higher risk of metastasis, and a higher risk of reoccurrence. It's also not responsive to hormonal therapies or targeted HER2 drugs.
Thank you, Dr. Webb. Do you have anything to add, Dr. Woods?
Everyone has shared some great information. I would add that it doesn't just affect women. While it's mostly commonly discussed in reference to women, it can also increase the risk of developing breast, prostate, or pancreatic cancers for men, as well as melanomas. Men developing breast cancer is quite rare, but it increased significantly with the BRCA gene mutations. Prostate cancer is also 5 times more likely and is often more aggressive and associated with a worse survival rate.
Thank you, Dr. Woods. Dr. Martinez, you mentioned germline inheritance. Could you explain more about germline and somatic inheritance and how it affects the BRCA genes?
Yes, absolutely. Germline mutations are mutations that occur in the reproductive cells like egg and sperm, making the mutation heritable. Somatic mutations occur randomly in other cell types and therefore cannot be inherited. The rate for mutations is much higher in somatic cells than germline cells in general. The BRCA mutation can be either germline or somatic. In the germline BRCA mutation, a non-mutated copy of the gene becomes inactivated in the cancer, usually due to an allele loss. In the somatic BRCA mutation, however, the mutation is only present in the tumor tissue. Somatic BRCA mutations occur in around 5 to 7% of ovarian cancer cases, with germline mutations accounting for more than 4 to 5 times that.
I appreciate you explaining that, and I'm sure our listeners do too. Dr. Vo, do you think you could explain some ways to mitigate this risk if you have a BRCA mutation?
I certainly can. There is a wide variety of ways for those with the BRCA mutations to lower the risk of developing cancer, as well as recommended treatment plans for those who have developed cancer with the BRCA mutations. Of course, treatment will depend heavily on each individual, but I can go over some common pathways. Chemoprevention is sometimes used, which is the use of some medications to help prevent cancer. Removal of the breast and ovaries and fallopian tubes is also recommended by some doctors.
Thanks for sharing this. Dr. Webb, do you think you could explain some treatments used if those with this mutation develop cancer?
Indeed, after the development of cancer, especially triple-negative breast cancer or ovarian cancer, certain targeted drugs like PARP inhibitors have been viewed as a promising solution. PARP stands for polyadenose disulfide ribose polymerase, an enzyme that helps repair DNA in damaged cells. They tend to be more impactful in cancers resulting from BRCA mutations. PARP inhibitors make it more difficult for the cancer to repair itself, which can lead to tumor cell death.
Thank you for explaining that, Dr. Woods. Do you think you could talk about how this impacts different populations?
Of course, since the BRCA gene mutations are hereditary, your ancestors play a huge role. People with Ashkenazi Jewish, Norwegian, Icelandic, and Dutch heritage are at increased risk for BRCA mutations. However, genetic testing can be valuable for all women. Additionally, in cases of mutation, 80% of African Americans have mutations in the BRCA2 gene, while 69% of mutations in European Americans occur in the BRCA1 gene.
Thank you all for joining and listening. Be sure to listen to our next. This has been Cancer Conversations, and thank you, of course, to our sponsors, the National Library of Medicine, the American Cancer Society, the CDC, and the National Breast Cancer Foundation.